Hey guys, so we're gonna kind of do a quick little review over enzymes and transport, just to make sure we're all on the same page and that type of thing. So, to first start, now again, I'll also say this isn't gonna probably be everything, but again, a quick little review, the high points, the heavy hitters, just to make sure that you have a good understanding of what's going on. Just in case you need a quick little review. So, the first thing is, this is my graph. This is my energy. This is my time. So, looking at enzymes, I'm going to use two different colors. This would be a normal reaction that would occur. And so, with enzymes, what we're going to do is we're going to lower the amount of activation energy. So we're going to decrease activation energy, and we're going to increase rate of reaction. Okay? That is the whole goal of enzymes. Now, from here, so again, decrease the amount of activation energy. We'll write what activation energy is. It's the amount of energy required for the reaction to occur. So the red is for without an enzyme for energy. The blue, I flipped the colors, hold on. There we go. The red, oh no. The red is the amount of energy required to go into the reaction for this reaction to occur. This blue here is the amount of energy without an enzyme for the reaction to occur. Okay, awesome. So we have two different types of reactions. We have endothermic and exothermic. This is my activation energy. And so I have to, my reactants and products have to be the same, and because I didn't release all the energy that I had to put in, I had to absorb it, known as endothermic. While in an exothermic reaction, this is my activation energy, this is my reactants, these are my products. I had to release, because I used too much energy here, I had to release as heat, also known as exothermic reaction. Okay. So remember that enzymes work in ideal conditions. These ideal conditions, going to choose a different color here, are pH. I think I did that wrong. I think it's pH, temperature, and let's just stick with temperature and pH. Sorry. Temperature and pH. So, a couple things that we have to do within this. So, if pH level, looking at graph purposes, you guys saw this in your lab. Something like this is my rate of reaction. This is my pH. This point right here, I just do this line. I'm going to put an arrow blue. This is what we would call my being most efficient. Okay, most efficient. Or most active. While anything lower than that or above in the pH would lower the efficiency or the activity of the enzyme, as you can see based off the rate. And so one other thing as well as we want to look at is we want to look at temperature, right? So that was pH. What does temperature do to enzymes? Well, rate, temp, here. So right here at this point, this would be my most active, right? Below, if I go lower or higher in temperature, I'm going to lower the amount of activity until we get to around this point. And this is what's going to happen when we denature the protein or the enzyme, where our protein has been folded and it starts to denature. And this is what's going to happen when we get to high temperatures. Okay? So now we're going to get into transport. So transport, we have diffusion osmosis, we have passive transport, we have active transport. Now, diffusion osmosis is passive transport, okay? It is still part of passive transport, but we call it two different things. Now, diffusion is movement of molecules, while osmosis is with water. Now, water is moved, as we know, from aquaporins in cell membranes. Neither one of these, no energy required, and they also go through concentration gradient. Okay, passive transport can be done in two different ways. We have diffusion, right? So diffusion is part of passive transport, and then we have facilitated. Facilitated diffusion is just like diffusion, or just like diffusion, except it involves a transport for a protein on the membrane to get it across because it's too big. And so it's still going to have no energy and still has high to low concentration. High to low concentration, or concentration gradient. Active transport, this is going to be the opposite. It's going to be low to high. Okay, it's going to require energy because we're going against the gradient. Energy, think ATP, by the way. And it requires a transport. And the perfect example of this, as you guys saw, is the sodium-potassium pump. And these work specifically within neurons and for muscles. All right. So give a little example here. While talking about cell membrane, this is my hydrophilic or water-loving phosphate heads. These are my hydrophobic or water-fearing tails. They're inside together. We also have cholesterol built in to stabilize the cell membrane. And it's a phospholipid. Phospholipid. lipid bilayer. Remember, this means 2 layers. Hence why 2 layers. Alright? So, going from this, we're going to draw this membrane here. This is the inside of the cell. This is outside of the cell. I'm going to use 2 different colors here. If I see this, and then I see this number, that is passive transport. It's also diffusion because molecules are moving from high to low without a transport. If I did the same here, but let's say instead of having the arrow, I drew this protein, still high to low. This would be facilitated diffusion because it's still high to low, no energy required, but uses a transport, or in this case, a protein. And then last but not least, I'm going from a low to high concentration. I see a transport here or a protein. I see the word ATP or using energy. Then I know it's going to be active transport. Trying to think of anything else that I can think of. The biggest thing is reading, like we did in the Pearson, is like the osmosis. The glucose couldn't move or the sugar couldn't move, so water was moving through the membrane. Make sure that you are able to, read through that. If you see that it can't passively go, then the water has to want to move. So that'll be bringing us to our last point. We have hypertonic, so these are dealing with solutions. So hypertonic, okay? Hypertonic, we're going to have more solvent and less solute. That's what that means. So remember our little cell here. We're going to have more water than salt. So less water, more water outside the cell. So flip that, sorry. So go back and flip that. We have decreased solvent, increased solute. So at higher salt concentration, so water's going to move out for it to shrivel up or shrink. Hypotonic, we have an increase of solvent and a decrease of solute outside the cell. So the cell's going to get big as a hippo or hypotonic. Isotonic, it is equal and water is going to flow evenly. Throughout the cell because it goes through randomly. That's pretty much it of the main high points. The biggest thing is just reading through, understanding what you're reading, what the question's asking you. One more thing with the enzyme. I didn't even draw the enzyme, so let's draw an enzyme real quick. So enzyme, okay, they are very specific to what's attached to it for what function it does. This right here is the active site of the enzyme, okay? This is my enzyme made of a protein. This is my reactant, or also known as the substrate. And once it finally attaches in here and then leaves and does something else, it is now my product. Okay, so other than that, that's all I've got for you. If you have any questions or whatever, please let me know, and I will see you on Monday.